Greetings fellow designers and welcome to CAD and Sorcery. It's been a while since I've wanted to create a beginner's guide video to help newcomers get started more easily. As someone who's been using SolidWorks for a long time and teaching it, I've learned what's essential for designers to know to bring their ideas to life. Mastering SolidWorks isn't just about knowing every tool by heart. It's also important to know when it's best to use a tool over another that can do the same job, and understanding how the software works in the background so you can make better design decisions. This comes with practice and experience. Now please understand that this video won't cover everything because that would take a lot more time. The goal of this video is to cover the basics and get you started on your SolidWorks journey. So probably this video might seem a bit too long, but I recommend paying attention to every moment of it. I promise you'll find the information valuable. Before we get started, make sure to hit the like button and subscribe to my channel for more SolidWorks content. Alright, I'm on my desktop and let's start by launching SolidWorks. By now you should have already installed the software. To run it, simply click on the desktop shortcut if you have one, or find it using the Windows search function like any other Windows application. In this video, I'll be demonstrating using SolidWorks 2024 edition, but rest assured, the features I'll show you are likely available in previous versions as well. The first time you run SolidWorks, you might encounter a license agreement or activation prompt. Simply accept and activate anything necessary before we proceed. On this page, you'll see the Welcome SolidWorks window, which may greet you upon opening the software. This window provides access to your recent documents if you have any. Additionally, you'll find tabs like the Home tab, which offers 3 buttons representing the 3 main types of SolidWorks CAD files: Part, Assembly, and Drawing. You can create a new document by clicking on any of these buttons. If you close this welcome page, you can also access these documents from the pull-down menus at the top of your window. The File drop-down menu provides access to several commands. Firstly, there's the New command, which allows you to create a new SolidWorks CAD model. Then, there's the Open command, which enables you to search for an existing document. Below these commands, you'll find access to your recent documents once again. For now, let's select the New option. Upon doing so, you'll notice the 3 document types appear. Allow me to briefly explain the differences between them to give you a basic understanding. A part document typically represents an individual component, such as a piston, a rod, or a wheel. An assembly document, on the other hand, represents a collection of components assembled together, allowing for motion between them. For example, a slider crank mechanism is an assembly. Lastly, we have drawings, which are 2D engineering representations of parts or assemblies. These documents contain all the necessary manufacturing information, including views, dimensions, annotations, and bills of materials. Now that we understand the basics, let's proceed to our first document, which will be a part. When you click on the Part Document button, a new window appears representing a virtual space where a model will be created. This area is called the Viewport or Graphics area. You notice that your user interface becomes populated with numerous icons and commands, many of which you may not yet understand. For now, I recommend avoiding unnecessary tools that you are not familiar with and focusing only the commands that I'll demonstrate. Directly below the drop-down menus, you'll see what we call the Command Manager, which consists of tabs containing various tools, also known as commands. These tabs organize your tools into different command families tailored for specific design tasks, such as creating sheet metal components or frames from rectangular tubes. However, this can quickly become overwhelming, so for now, I suggest right-clicking on a tab. From the right-click menu, navigate to Tabs and disable all tabs except for Sketch, Features, and Evaluate. These are the essential tabs for beginners, while the rest will be useful in the future. The Sketch tab provides access to tools related to 2D sketching. The Features tab contains commands for converting your 2D sketches into 3D geometries, cutting these geometries, or directly editing 3D volumes. Lastly, the Evaluate tab gives you access to commands for taking measurements of your model. To create a 3D volume, or what we call a boss in SolidWorks, we first need to start by creating a 2D sketch. These sketches are placed on flat areas known as planes. Think of planes as drawing boards where we begin our designs. By default, each part document contains 3 2D planes: the front, the top, and the right. These planes intersect at a point. This point is called the origin. Essentially, it is the center of our virtual environment. There are several ways to begin drawing on any of these planes. The first method, which I recommend for beginners, is to go to the Sketch tab and activate the Sketch command. Once selected, you can then choose one of the 3 default planes. The second method is to simply click on any of these planes and from the menu that appears next to your cursor, choose the Sketch command. Lastly, you can also left-click on the plane you want to use, then go to the Sketch tab and choose the Sketch command again. These 3 different methods all initiate the 2D sketching process. For example, let's choose the front plane. As you select it, you'll notice that the plane rotates so that it's directly perpendicular to us, ready for sketching. For beginners, it's crucial to always maintain a perpendicular view to the drawing planes. If, for instance, you accidentally rotate your camera angle, it might seem like you're making mistakes in your design when in fact it's just your camera angle that is off. You can verify this by checking the triad at the bottom left of your viewport. Ideally, you want one axis to point directly or opposite to you to ensure perpendicularity, so this rectangle looks like a parallelogram from this point of view. Now let's explore some basic techniques for manipulating your point of view. Pressing and holding the mouse wheel allows you to rotate your view. Rolling the mouse wheel towards you zooms in, while rolling away zooms out. Pressing the control key along with the mouse wheel allows you to pan. As you become more familiar with SolidWorks, you'll discover additional ways to manipulate your point of view. However, for now it's best to stick with these basics. Even with these techniques, you may find that your view isn't perfectly perpendicular to your model. To correct this, you can use the View Orientation command. This command can be accessed from the Heads-Up View toolbar at the top of your viewport or simply by hitting the spacebar on your keyboard for a quicker option. The Normal To option within this command instantly brings you perpendicular to the drawing plane, ensuring a proper view. Pay attention to maintain this perpendicular viewpoint to your drawing plane so you won't make any mistakes. You may have noticed in other tutorials of mine that I quickly switch among different views. This is because each command has keyboard shortcuts associated with it. For instance, Normal To can be activated by pressing Ctrl+8 on your keyboard. While this may seem awkward at first, I encourage you to learn and utilize shortcuts early in your design career. They'll make you faster and more efficient with the software. Some of you may see a cube appear when hitting the spacebar. This is because the View selector is activated. Clicking on any face of the cube brings you normal to that orientation. You can toggle the View selector on or off by clicking on this icon. So to always maintain perpendicular view on the sketch plane, remember these tips. And don't worry if the plane you're working on isn't visible. You don't need to see it all the time. However, if you prefer, you can left-click on the plane and choose the Show option with the eye icon for added reassurance. Now that we're perpendicular to our drawing plane, let's explore the various sketch tools that SolidWorks offers. The Sketch tab provides us with a range of tools to draw basic shapes. As you move from left to right on the tab, the tools become more advanced and complex, and some tools are only available and can assist your design after you've used simpler tools. For instance, commands like Mirror or Pattern are inactive until you've designed something first. Let's focus on this section of Sketch tab, which contains 12 tools with alternate options accessible from the arrows next to the icons. But before we begin sketching, let's discuss the proper hand positioning on the keyboard and mouse. If your dominant hand is the right hand, you'll use the mouse with your right hand, while your left hand rests on the keyboard. Position your thumb above the spacebar and your other fingers covering the leftmost area of your keyboard. For left-hand users, as you understand, the position is the exact opposite. Depending on your keyboard, it's essential to have your middle or ring finger on the Escape key, as it's one of the most important keys in SolidWorks for closing commands quickly. A common mistake for new designers is trying to initiate specific features while a command is active, so the Escape key is crucial. Keep it close. The spacebar is also important for your thumb, while you can quickly access the Control key, especially for multi-select, which we will cover later in this video. So let's focus on sketching for now. To start, we have the Line tool. Once I initiate the command, the symbol next to the cursor indicates that the Line tool is active. In SolidWorks, to draw a line, you first left-click at the beginning of the line. As you move your cursor, you'll see a preview of the line. Once you've decided on the position and orientation, left-click again to complete the line. You can continue drawing additional lines by left-clicking at the endpoint of the previous line or until you create a closed contour. Or press the Escape key on your keyboard. You can also draw a single line continuously by pressing and holding the left mouse button. The remaining tools work similarly. Let's take the Circle tool for example. SolidWorks provides useful icons throughout the commands. The Circle tool, for instance, offers two choices: the Circle option, where you define the center and radius, and the Perimeter Circle option, where you define 3 points to create the circle. SolidWorks offers various options within its sketch tools to accommodate different design needs. For example, if you know the center of your rectangle, you can use the Center Point Rectangle tool. I encourage you to explore and test all these tools to understand how they work. Remember to press the Escape key when you're done with each tool. As I design, you'll notice that while I have a tool active, the left part of my user interface changes between different tabs until I close the current tool. These tabs on the left are called Managers or Manager tabs. The default tab is the Feature Manager tab, which helps you manage your features. However, the second manager, also known as the Property Manager, assists you by providing options for your currently selected command. For example, if I choose the Line tool, I'm given the option to make it for construction, creating a dashed line. If I choose a different tool, like the Polygon tool, I might be presented with extra or completely different options, such as the number of corners for the polygon. There are many options here, but it's best to focus on the simple properties first and do not rush. With time and practice, you'll discover what works best for you. Keep in mind that the Property Manager initiates either by activating a tool or by simply choosing an already created entity on the viewport, like a line. For now, I want you only to focus on these two managers and forget about the other manager tabs. Alright, let's clear the canvas a bit. To delete an entity, which is what we call all sketch elements used in a 2D sketch, like a line, circle or arc, you can either right-click on it and choose the delete command, or you can left-click on the entity you want to delete and then press the delete key on your keyboard. To quickly delete multiple entities at once, such as these three here, you can use multi-select in the sketch. Simply hold down the Control key on your keyboard and left-click on each entity you want to select. This will highlight all selected entities with a light blue color. Once you've selected all the entities you want to delete, you can press the Delete key on your keyboard to remove them. But what if you want to select even more entities? You can create a selection box by clicking and dragging your mouse from left to right. Any entity fully enclosed within the box will be selected. Alternatively, if you drag your mouse from right to left, a green box will be created, and any entity it touches will be selected. This is a great way to select everything within the box. If you want to ensure you've selected all entities in your sketch, you can simply press Ctrl+A on your keyboard to select everything. Then press the Delete key to eliminate all selected entities at once. This is a handy shortcut to clear your canvas quickly. Additionally, you can move selected entities around by pressing and holding the left mouse button on the entire entity or an endpoint of that entity, then dragging it around. The movement of the entity may be restrained depending on the current relations given to the 2D geometry. Furthermore, this action can also resize any entities based on the currently given relations to the geometry you've designed so far. By accessing the Edit pull-down menu, you can find the Undo and Redo commands, which are common to most Windows applications. Alternatively, you can activate these commands using keyboard shortcuts, Ctrl+Z for undo and Ctrl+Y for redo. These shortcuts provide a quick way to undo or redo your actions as needed. At this point, delving into the intricacies of every tool will consume a considerable amount of time. Instead, let's focus on something more fundamental and beneficial for beginners: the sketch status. As you may have observed earlier, I can freely drag and adjust the size and position of my entities while sketching. However, what if I want to maintain relations and dimensions of these entities and ensure they are modifiable in safe and controlled manner? If you direct your attention to the bottom right of your status bar, you'll notice the text under Defined. This denotes the current status of your sketch. When a sketch is labeled as under Defined, it indicates that there is missing information to stabilize the sketch. Our goal is to transition from being under defined to being fully defined. To achieve a fully defined sketch, we need three key elements: relations, dimensions, and a relation or dimension linking our geometry to the origin of the sketch. Let's delve deeper into these aspects. Sketch relations are geometric constraints between sketch entities or between a sketch entity and a plane, axis, edge, or vertex. These relations can be added manually by selecting an entity and navigating to the Add Relations section in the Property Manager. Here, you can choose which relations to add. For example, selecting the vertical relation will ensure that a line remains vertical regardless of how its endpoints are dragged. A green box indicates the type of relation applied. To remove a relation, you can right-click on it and press Delete. Or left-click on it and press Delete on your keyboard. Alternatively, clicking on the line reveals its existing relations in the Existing Relations field, where you can delete them from there. You can also Control-select multiple entities and assign additional relations. Exploring different combinations of entities allows you to discover various relations such as parallel, equal, concentric, perpendicular, and coincident. Relations can also be added automatically. For instance, when drawing a line to create a rectangle without using the Rectangle tool, yellow guiding lines appear to indicate potential relations. The yellow lines signify automatic relations that will be applied if you click the left mouse button. Also, a yellow box appears indicating which relation is going to be applied. On the contrary, white box relations do not apply automatically and do not restrain the movement, requiring additional actions to enforce the vertical alignment in this example. So we must add a vertical relation between the 2 points or draw a connecting line. SolidWorks is tailored for engineers, so working with precise dimensions is fundamental. We can define these dimensions by using the Smart Dimensions tool. Simply click on the Smart Dimensions tool icon and the cursor will change to indicate that the tool is active. Clicking on an entity, such as a circle, allows you to insert a value for its diameter. After left-clicking again, a Modify window appears, enabling you to input the desired value. Confirm the dimension by clicking the green checkmark or pressing the Enter key. To modify a dimension, double-click on it. To delete it, click once and press the delete key or right-click on it. Same with relations, let's explore different options. When selecting 2 points, you can get the direct distance between them. However, be mindful that moving your cursor vertically, the tool gives you the vertical distance, while moving horizontally, you get the horizontal distance between the 2 points. To avoid giving a wrong dimension, simply right-click once to lock the dimension orientation you prefer. Also, to avoid mistakenly clicking on other sketch entities, click once when you are further away. I encourage you to select multiple entities to explore the dimensions you can get. Selecting a line gives you its length, or you can get the horizontal and vertical dimensions. While selecting non-parallel lines, you can get the angle between them. By choosing 2 parallel lines, you can get the normal distance between them. By choosing 3 points, you can get the angle as well. Finally, by selecting 2 circles, you can get the distance between their centers. I'll let you experiment and discover the rest by yourself for now. Keep in mind that while adding relations and dimensions is essential in SolidWorks, it's crucial not to overdo it. SolidWorks is parametric design software, meaning it is driven by dimensions and relations. For example, if a line equals 100 mm, due to the geometric relations I've specified, adding another dimension for the same line will be redundant. Additionally, excessive use of relations may lead to design paradoxes and over-definition of the sketch. During the insertion of dimensions and relations, our sketch entities may turn red and yellow. This indicates that the sketch is over-defined and no solution can be found, resulting in a design paradox. For instance, a line cannot simultaneously be both horizontal and vertical. To resolve this, one of the conflicting relations must be deleted by right-clicking and selecting Delete, or by pressing Delete on the keyboard. When sketch entities are blue, this means that they are in an underdefined state. Having at least one underdefined entity makes the entire sketch underdefined. To make a sketch fully defined, all sketch entities must be fully defined first. In an underdefined state, sketch entities can be modified to some degree while maintaining existing geometric relations and dimensions. For example, the value of 150 mm will remain constant regardless of how much I move this endpoint. It will only change if I manually adjust the dimension by double-clicking on it. Similarly, if I don't delete this vertical relation, the line cannot be freely moved around. That's why this underdefined state represents a lack of control, which is why it's crucial to have both relations and dimensions to govern the behavior of our model. Many beginners fall into the trap of leaving sketches underdefined, which can lead to unintended mistakes. So our goal is to achieve a fully defined state where all necessary dimensions and relations are applied, resulting in a sketch entity displayed in black color. Let me demonstrate by designing a rectangle. You'll notice that the 2 lines forming the rectangle are already black. This is because we intentionally placed the corner of our rectangle on the coordinate system, acting as an anchor for the line, which also have horizontal and vertical relations. Think of it this way. Currently, this point has a fixed position on the xy coordinate system at point 0. This is our origin. However, the endpoint of these lines is not fixed on the xy coordinate system. To fix their locations, we need to add dimensions to define their positions. By doing this, I've reduced 1 degree of freedom for this point, allowing it to move only along the y direction. Adding the last dimension ensures that nothing can move and my sketch is fully defined. The black color of each entity is a good indication to know that our sketch is fully defined. Of course, I can still modify the dimensions if needed. Alright, now that we have created a sketch profile, let's move to the Features tab, where our 2D ideas can be transformed into 3D geometries. While there are many tools available here, you'll notice that most of them are not currently applicable to our 2D geometry. The most basic tool here is the Extruded Boss command, which allows us to turn our 2D sketch profile into a 3D geometry by extruding it normal to the plane where it was designed. When we click on this command, the camera angle changes so we can view the object in 3D. The geometry about to be created is highlighted in yellow. As you've already noticed, the Property Manager appears once we initiate the command. There are many options available, but for now, let's focus on using Direction 1 for extrusions. So, from the Property Manager, we can control the depth of the extrusion. For example, I can change the depth from the default 10 mm to 50 mm. Additionally, I can alter the direction of the extrusion by clicking on these arrows. Note that even with the Extruded Boss command active, I can still rotate the model to better visualize the results before confirming the command. If you want to extrude in the opposite direction using a different value, you can utilize the Direction 2 field. To finalize the creation, we simply hit the green checkmark either on the top of the Property Manager on the left or at the top right corner of the viewport. You'll see the geometry is created and we can rotate around to see the model we just made. Last but not least, in the Feature Manager, you'll notice a new feature at the bottom of the design tree. Beneath the origin, you can see the Boss Extrude 1 feature that we just created. But what happened to our sketch? If you take a closer look at the Boss Extrude 1 feature, you'll notice a small arrow on the left. Clicking on this arrow expands the Boss Extrude 1 feature, revealing the sketch we used. But what if I made a mistake on this sketch and want to modify it? Before we proceed with designing our ideas, we must be prepared in case we want to make modifications to our model. I can either left or right click on the sketch and choose the Edit Sketch command. By doing this, the sketch opens and now I can edit dimensions, relations, or even add new entities to modify it further. For instance, let's change that dimension here. When editing a sketch, I can either click on the pencil icon to apply the changes I just made, or I can click the X to negate the modifications I just made. This flexibility allows us to refine our design easily, ensuring precision and accuracy in our models. In case I want to modify the extrusion I just made, I can similarly left or right click on the Extruded Boss feature and choose Edit Feature instead of Edit Sketch we chose earlier. The Property Manager appears and from there I can change the extrusion depth. Again, by clicking the green checkmark, our modifications apply, while clicking on the red X negates our modification. This feature allows for easy adjustments to our model, ensuring it meets our design requirements accurately. Now that we have a solid body, we can continue adding features to our geometry, and we can also open new sketches on planar faces of our currently existing geometry. Let me show you an example. I'll click on that face and choose the Sketch command from the Sketch tab. I will draw a circle. My sketch is fully defined and I will go to the Features tab and use the Extruded Cut feature. This is the exact same as Extruded Boss, but instead of adding volume to your model, it cuts the solid geometry. Of course, if I wanted to, I could also create a new sketch on the pre-existing planes that SOLIDWORKS offers, and this can be done by clicking on that plane and then choosing the Sketch command once again. So keep in mind that for now as beginners, you can only sketch on a 2D plane or on a flat surface. If you were to try and start a new sketch on this cylindrical face, you'd notice that this cannot be done. There are plenty of features, but I cannot show you all these tools in such small video. Again, I suggest you begin learning from simple geometries and use basic commands as much as possible. That's how you'll become better, so rule of thumb is keep it simple. As I mentioned before, there are commands that do not require a 2D sketch. The fillet and chamfer commands are such tools. Let me show you how to fillet these edges. The fillet command contains a bunch of different options in the property manager. We'll keep it simple by using just the blue box called Items to Fillet, where you select the edges that you want to fillet. Then, go to the Fillet Parameters section and input the value of the fillet you want. Again, the green checkmark closes the command and applies the fillet on those edges. SOLIDWORKS features that I have created so far line up from top to bottom in a chronological order. This means that the order of the features in the design tree is important and affects the geometry of the model. This blue bar here is called the rollback bar, and it allows us to move it between the features. When the rollback bar moves above a feature, this feature vanishes from the viewport and it's like it still hasn't been designed. We can even go at a time when there was no features at all, and that's directly beneath the origin. I can also move the bar lower to return to where I was. This is called roll forward. So I want you to think of rollback bar as a time-traveling machine which allows you to go back in time and build features in that specific place where the bar resides. The new feature is created directly above the blue bar. So while in the real world this Boss Extrude 2 feature was created after the fillet feature, thanks to the rollback I could place it chronologically before the fillet. Also, I can drag and drop one feature above another, and this is the part where I want you to notice that the model is different when the Boss Extrude is created prior or later to this cut extrude. Now if I want to delete a feature like this fillet for example, I can right click on it and choose the delete command. I can also delete this feature by left clicking on it, then press the delete on my keyboard. This is the part of the video I want you to really focus on. I want you to take a very close look at our model. You'll notice that 3 of the faces of my box are exactly on the 3 default planes. Let's edit that sketch to see why this happens. You'll see that I designed my rectangle to have this point coincident with the origin. Even if it seems correct, the best practice here is to make your model be in the absolute center. We can either do this by adding relations, or if we had to do this from the beginning, we could use a center point rectangle. If we wanted to do that as we are, we would have to delete all the relations that prevent us from moving this geometry. As we mentioned earlier, we can either delete these relations by right-clicking on the green symbols and choosing delete, or simply left-clicking and pressing delete on our keyboards. Also, do not forget, by choosing an entity, you'll notice that the property manager in the field existing relations contains all the necessary relations which you can delete from there. The best thing is that I can move this around without having the dimensions or the other relations break. But now, I must fully define my sketch in some way, and that would be by either giving relations or dimensions to my model. So which one is the best to use? There's something we call design intent, which is a huge chapter and it would take some time and see some examples to properly explain it. But think of design intent as the behavior of your model when its dimensions are modified. So in this model, if I want this rectangle to be exactly in the center, I would have to add half the dimension on the X and half of this dimension on the Y. But what if these dimensions change? In that case, the condition I added is completely wrong and I lost the center of my rectangle. So that would be wrong judgment from design perspective. Instead, it is safer to add relations between the line centers and the origin. By right-clicking on a line, you can choose midpoint. This chooses the midpoint for that line, no matter where you click. And with the Ctrl key pressed, now you can also choose the origin and insert a vertical relation which locks the x-axis orientation. Now we can do the same for the other line to make this rectangle be in the center. Once I close the sketch, you can see that the right and top plane cut exactly in the middle of this rectangle. To make the front plane cut in the center of this box as well, we can edit that feature, and instead of having this to a blind end condition, that's how we call that, it's an end condition, you can instead change it to mid-plane, so you can have that plane cut your box in half as well. Designing our objects in symmetric ways allows us to utilize features in a way that reduces our design time dramatically. You can save many hours of design that way, so the rule of thumb here is always respect symmetry. It's important to learn how to design correctly early on, and that way you'll have a lot easier time learning the software, trust me. As engineers, one of the reasons we design is to extract valuable information from our models. We can create 2D drawings, assemblies of mechanisms, bills of materials, use finite element analysis for simulations, motion analysis, and even more. As you understand, I can't cover all this in one video, but I'll show you 2 tools you can use in the Evaluate tab, which I want you to learn how to use. Before I show you the other tool that I want, let's have a look back on our design tree. As you can see, there's a place for material here. Normally, what we design can have a material assigned to it, which we are going to use for manufacturing. So let's say that I want to create this model from stainless steel. As you can see, the properties for each material are summarized here. I don't want to get into detail, but I have covered this in another video, which you can find here. For now, let's assign this material to this model, and let's see what valuable information we can get from it. This command can show you everything about the mass properties of your model, and the reason I am showing you this is the mass itself. Here we can see how much our model weighs. And this is important to beginners who aspire to take the SolidWorks certifications, like the Associate or Professional SolidWorks exams, because that's one of the ways you get tested. But that's a really deep topic, which I can cover for you in another video if you're interested. Just leave me a comment so I know. Generally, you can measure your model by holding the Ctrl key and clicking on 2 faces you want to get the measurements for. The distance between these 2 faces is written at the bottom right of your status bar. If the 2 faces are angled, you would get the degrees between the 2 faces. Or you can use a line to directly get its size, a circle to get the diameter, etc. Of course, there's a dedicated tool that makes these measurements even more accurate. This is the Measure tool in the Evaluate tab. It allows us to choose anything we want inside the blue box. There are lots of options here. I want you just to focus on the XYZ dimensions or the direct distance between the 2 points I've chosen. Again, choosing angles can be seen here. Until the end of this video, I'll fast forward into creating something so you can have a look at the capabilities of the software. I'm going to leave this video here, as I believe that it answers some of the questions you might have as beginners. At least with this video I hope you have some easier time learning. But feel free to write in the comments what topics you would be interested in analyzing next. Also, if you have any questions, I'll be happy to answer in the comments below. If you like this video, don't forget to hit the like button and subscribe to my channel for more SolidWorks content. Thank you for watching.